Hello and welcome to the third series of Exploring Global Problems. In this podcast, we talk to academics from Swansea University whose groundbreaking research is tackling global challenges, from health innovation to sustainable futures and the environment, from digital technologies to clean energy. My name is Sam Blaxland, and today I'm joined by Dr. Alvin Orbaek White, formerly an associate professor in chemical engineering here at Swansea University. He is a researcher, innovator, and now entrepreneur, and has recently started up his own sustainable energy company. Alvin's research focuses on global energy security, especially the materials we need for this and how we source them sustainably. Much of his work involves exploring material circularity, or how we make new and innovative things out of old materials. Alvin, welcome to Exploring Global Problems.
Nice, thank you very much.
It's good to see you. Can we start just by getting a sense of what your research is about? So just give me an idea about what you do and what your key findings have been so far.
Yeah, absolutely. So it all comes down to the basis of energy. Without energy, a lot of things would be impossible to do. And in order to generate, transmit, or store energy, you need materials to do that. So thinking about this from the perspective of, well, there is no planet B, how do we utilize the materials that we have at hand to the best of our abilities and do that in a meaningful way that is sustainable as much as possible and has the highest potential impact for the users and for all the stakeholders involved. So the key findings I've found is that there is a huge amount of waste materials available, and there is chemistry and engineering that is available and even off the shelf that we can utilize to harness that materials. It's just really that we need to spend our time doing it and dedicate our time towards it. So for example, in terms of plastics, which is something that I focus on now because it's a hydrocarbon material, and hydrocarbon is one of the backbones of all the materials that we tend to use. Hydrocarbon means it's made out of hydrogen and carbon. Plastics are a classic example, solvents and petrochemicals. On the planet right now, there's 83 million metric tons of plastic that has ever been made, and about 60% of that is in the environment. So it got used once, maybe it got recycled, but it got put out to pasture, so to speak. And the consequence of that is that we're eating or consuming or inhaling that plastic material to the extent of about one credit card worth each week.
Okay. So in the introduction, I talked about this idea of circularity. Now, you mentioned recycling there. The two aren't quite the same, are they? Or are they? It's just circularity a posh word for recycling?
You'd have to speak to experts on the aspect of the nuance between circularity and recycling. And there is sometimes when I use those words interchangeably.
Yeah.
I think for me, when I say recycling, it's an umbrella term for the conventional technologies and the conventional pathways that we utilize right now. Circularity has been around for actually quite a long time. I mean, farmers have used the concept of circularity for a very long time. Look at the way that we have milk products and cheese products, because the farming communities didn't want to waste that material. And so they found other ways that it could be utilized. We've had circularity for a very long time. I think the distinction now that is starting to arise or has arisen is that we need to dig deeper into the materials that we're considering for recycling or considering for circularity. And that is where the new avenues of science are starting to come around.
Which is very much what you're doing. I've looked up a little bit about your research and it's very interesting. There's an element, I know we'll talk more about it in a minute, but there's an element almost of, to my mind anyway, of upcycling here in some ways, of taking rubbish and turning it into really quite interesting, cool stuff. Is that fair?
Oh, absolutely, yeah. And I for a while I've been I've been toying with what's the correct terminology for this? Is it recycling? Is it circularity? And I even considered it as upcycling for a time, but upcycling already has a connotation, and so in a way it is upcycling because you are generating a thing that is more valuable or contains more value than the original item itself, or the same pathway if it was recycled. Just to focus on that point about upcycling to make things more valuable, part of the philosophy that I have in my working is to think that the problem that we're trying to solve, look at that and realize that the solution is in the problem. Okay, and so when you think like that from really quite simplistic philosophy, you can tease out you can tease out the chemistry and the material science and the engineering if needs be, or when needs be. But to look at the problem and say, right, inside here there's a solution inside this. What I've come down to is that the recycling, if you use engineering or mathematic parlance, the equation for recycling is quite simple. Plastics goes in equals plastics comes out. That's recycling, okay? And the challenge with recycling is mainly down to the fact, and I'm just simplifying things right now. It mainly comes down to the fact that the value of the plastic going in is higher than the value of the plastic coming out. The plastic coming out is more brittle, less formable, discolored. Basically, it's worthless compared with the plastic going in. And for as long as that exists, I believe that the problems with recycling and problems with plastic will continue. So in order to change that concept, I looked at this and thought, well, what if we can make something that is more valuable? So you have plastics goes in equals something more valuable come out.
Yeah. And we'll come to that in a second. I'm really interested with some of these not inventions. It sounds too Wallace and Gromit about it. But some of these things that you've made, they're fascinating. But just before we get there, energy is the starting point here for you. You said, and I'm sure a lot of us have some sense of why it's so important. But why is energy the really critical thing here?
Ooh, I mean, if you want to do anything, you need energy. I use this example every year. I teach heat transfer, and unfortunately this year we've had a situation in Syria and Turkey where you have an earthquake, and one of the first things that's going to start happening is they're going to start needing energy. They're going to be pulling out generators. They're going to start, filling up, trucks, moving things around. All of that requires energy. Work, to do that work requires energy. One of the things that struck me recently is when I saw the drone footage of the devastating imagery and scenery that I saw there. I was pleasantly surprised to see how many photovoltaic cells I saw there. Previously you would imagine there'd be a lot of diesel generators or things like this to get energy, but now obviously things have moved on. That right in an emergency situation, one of the first things you can do is start rolling out these photovoltaic cells, charging batteries. You can call home. You can transponders and radios can start talking to each other. I bring that example up because there's a scenario where you've got nearly nothing else except for life, and you're on the brink of life. And the first thing you need after food and water and hope is energy, and then shelter. And it's a fundamental tenet of our way of life, and we are so used to it that we forget that we need it.
Absolutely. It's like when there's a power cut and you still go to do things without realizing that you can't put the kettle on.
Open the fridge up.
Yeah, absolutely. Yeah. Now, you've worked or studied a lot in the US. You were at MIT and you worked in Texas. So what were you doing out there?
I did my PhD in Texas, in Houston, Texas. I did my PhD in Rice University. I specialized in the synthesis of single-wall carbon nanotubes. These are the form of material that I make now as well, but they're a very specialized type of material. And in MIT, I continued that line of research. I developed a technique for making very long, what we call ultra-long single-wall carbon nanotubes. What I did over there what happened to me over there is I saw a whole new avenue of research and possibility. I'd never really heard of nanotechnology, even though I was really interested in physics and science. And to cut a long story short, I started a PhD in Barcelona, actually, and my project was to make a device that could work on the moon so that you could analyze the regolith up there and at the same time produce photovoltaic cells from the silicon. And it required the small little molecule called a carbon nanotube. And I was like, what is this small little thing? It's tiny. Like I read, it's 1 nanometer across. That's about the size of your DNA, 80,000 times thinner than your hair. Stronger than steel, lighter than steel, conducts electricity, acts like a semiconductor, but it's made out of carbon, so it's an organic material. So what is this? And so I was really fortunate and to have the opportunity to go to Rice University and work very specifically on the question of how to make carbon nanotubes. And so my advisor there, Professor Barron, was a specialist in this. And I thought to myself, right, I'm going over to the States it could only be for a short period of time. I'm going to think about this like if you go to a cobbler and you want to learn the trade, I go and I learn the trade. And I enjoyed it so much, and I did fairly well, and I stayed quite a bit of time, enough that eventually, I got an invitation to work at MIT.
Which is very prestigious.
It's well known. Yeah. For good reason. They're very, very eager and interested people. The dynamic there is fantastic. There's a real... It's challenging. One person said to me, it's very common you go toe to toe here. Like you have an idea, someone else has an idea, and you go toe to toe, amicable, professional, but you really get down to the bare bones of ideas and things like this. Yeah.
Did you go toe to toe with anybody in particular?
Of course, you have to. I mean, you have there's learning in that. You're put to a position where you have to defend, and you find out either that you're right or you're wrong, and then either you're the one who learns or the other person is the one who learns, and then you just move on.
Absolutely. What was working in the States like in general?
For me, it was a really wonderful experience. In hindsight, looking at it, I think I had like the immigrant complex, wanting to go over there and maximize my time as much as possible. I found something there that I carry with me always, and that is I'm inspired by how optimistic they are, and Americans can get a hard time for being so optimistic compared to in the United Kingdom. But when you come up against almost intractable problems, seemingly intractable problems, optimism and hope is what you need. And you find if there's only one way in a million that it works, then you start there. All the other ways that it doesn't work, that's fine. You can find experts all over the world who can tell you how it won't work. But finding an expert who will find you one way that it will work, or who will have the willingness to find that one way that'll work, that's what I learned. And that's something that I take with me, and I love that.
How does your journey, as it were, take you from the States, from MIT to Swansea?
It's all about vision. It boils down to vision. When you get to, I explain this to my students as well, and it's interesting. I had this conversation very recently with one of my students who's now got an opportunity to go to the States. And when you get to the level of lecturer, senior lecturer, associate professor, so on, it's like a pyramid. You learn less and less about, you learn more and more about less and less. You get up to this pinnacle, and so you become extremely highly skilled and very knowledgeable in a certain area that maybe not everybody aligns with. And so even though you might have, or I came from a place like MIT, it was still a piece of work to find places that saw my vision and saw how it aligned with their general vision in their campus or in their university. And that's what I found here, and that's why I came.
Great. And how long have you been here for?
In September, it'll be 7 years.
Great. I know you like sailing as well, so
I love sailing.
Swansea's a good place to be.
Yeah, unfortunately, I've really only had an opportunity to sail once. I have been asked other times to sail, but the typical times that people sail here are the times that I'm usually gone to conferences.
Yeah. Carbon nanotubes, then, or CNTs, as I believe they're called. We'll call them CNTs. You've touched upon this already, but in a nutshell, why are they so important?
They're incredibly versatile. And what I mean by that is, again, they're very, very strong, very, very lightweight. They're very, very robust, chemically resilient. They can withstand very high temperatures, very low temperatures. They can conduct electricity. They can transmit heat. We've shown them to transmit data. They are flexible. So you can imagine very strong wires, cables, cords made from them. You can imagine very strong, lightweight threads and fabrics made from them. They are broad spectrum absorbers and receivers. So they are basically like a black body, which means they can absorb all the energy which is incident on them. So that's why they look so black. Incidentally, the world's blackest material are carbon nanotubes. They are somewhat challenging to make, but easy when you know how. So they're versatile in the way that, predominantly industrially they will be made using very refined petrochemicals. now I've shown that you can make them with a more wider range of carbon materials, face masks, for example, polystyrene. They have a wide variety of uses. They get incorporated into concrete, into cement, so that they make the cement more heat conductive. So instead of having cold spots in houses or homes, the homes share the heat. Okay, so you won't have the north side more cold than the south side, for example. Yeah, so you can have this heat transfer much integrated into the passively integrated into the home. You can have much more flexible steel. It looks like the steel that was made in the 12th century, called Damascus steel, had carbon nanotubes in them. These swords were renowned for being lightweight, flexible, very sharp, very strong. You didn't want to go up against them. It turns out years later, I mean, it was 20 years ago or 15 years ago, they used electron microscopy imagery to find out that there's actually single wall or multiple wall carbon nanotubes in the steel that they were making in the 12th century. So this material has been with us for a very long time.
That's given me an opportunity to put my historian's
hat on.
Yes,
please do.
But how is this stuff in this 12th century material?
I have a theory on that. I took that theory to a blacksmith, and with two blacksmiths and myself, we put that theory to the test. We've been working with black powder, carbon black powder, as Homo sapiens and our human ancestors have been using black powder from fires for a very, very long time. There must have been something, and so over time. Also, we got into metallurgy, and we make, you get iron, you add carbon to iron, you get steel. So somebody must have recognized there was something special about a certain type of carbon that they were using that made a certain type of steel. So they didn't have electron microscopy, but they must have had a much stronger sensitivity or sensibility to the material handling or the material performance. So this art of blacksmithing, very highly skilled work. These people must have recognized there was something about a certain type of soot, and they must have learned how to make this soot. One of the pieces that I've put together in the puzzle of where it comes from or how we know about it, historically, there was an article written in the 1970s for the Journal of Chemical Education. Great journal, actually, and this was called Colloidal Soot, The Magic of Colloidal Soot, I think was the title of the paper. In that article, the author wrote about how colloidal soot is now found in ink from the Roman period. And the reason why some of these artifacts still exist and we can still read them is because the ink still survives, because it has these nanomaterials, like I said earlier, are very chemically resilient and very chemically robust. Now, how did they know about that back then? That is something that I'm really curious about, and I've asked various historians, and I'm still open to hear from other historians about what they might think. Someone has probably read an account of somebody being a blacksmith and maybe not realizing what they're reading, that someone is like discussing there's certain soot that they would use over other soot, and in that formulation, in that description, is probably a formulation for how it was made way back in the day. One description I've read suggests that they used dried pine branches, and then they would burn that, and they'd get an instant hot flame, and then they would douse the smoke on cold marble slabs. So the smoke would condense very quickly, and then that soot that was condensed there, that was the colloidal soot that they would put in the ink.
This is true interdisciplinary stuff here, really, isn't it?
It's fascinating.
Yeah, brilliant. I was going to ask, what are typical materials made from or with CNTs? I mean, I wasn't expecting medieval weapons and ink, but which is absolutely fascinating. Obviously, I love that. But if we are talking about the more typical uses of these things, it's the cables, isn't it? It's the things that you were mentioning a moment ago.
Yeah, the cables is the vision that I have, and many others share that same vision. The cables predominantly are still using metals right now, but I believe that will change eventually in the future for a variety of reasons. Right now, you can buy devices that have carbon nanotubes in them. You can buy headphones that have carbon nanotubes in them. One device that a colleague Varun, my colleague, has pointed out to me, is because they conduct electricity and they're not metallic, they can be used in MRI scanners. Right. So when you're in an MRI scanner, it's a big whirling sound. You can't hear the operator, and maybe you have to move left or hold your breath and things like this. Now you can wear these headphones that are, the casing is made out of plastic, but the electronic componentry inside it is made out of carbon nanotubes. So now you can interface by radio waves with the operator. Whereas if you use metal, I mean, the magnet would just pull the headphones right off your head. So there's one way it's being utilized right now. You can use them for batteries. And this is the thing that I'm thinking about now, is where the big use case scenario will be, because in batteries, they're commonly used as a conduction platform, and they're chemically resilient so that they don't degrade over time. So they should give additional lifetime to batteries. And they're lighter weight than metals, so they should eventually make batteries lighter weight as well. So one of the aspects with electric vehicles is mass. I mean, it's one of the aspects with all motors or vehicles in general, because you've got to work against gravity all the time. And electric vehicles are nearly 1.5 to 2 times more heavy than a traditional car, because they've got these additional metals in the batteries and the solenoids and things like this. So these are places that are both where nanotubes are both being utilized now, and where I see them being utilized in the future.
It sounds so innovative. Things I've put to guests in previous episodes of this podcast, when we've been talking about things like energy generation or climate change, and they've been very concerned and worried about the future. And I've put a point of view to them sometimes, which is that we will innovate our way out of this in some ways. Things will not come to the rescue per se, but human ingenuity will help overcome some of these really, really big problems. Is this not proving that point to an extent?
Yeah, so on the topic of whether we're going to innovate our way out of the scenarios that we have in the future, yes, we have the ability to do it. We have the ingenuity to do it. The one key factor that we all need is to maintain hope.
And I know that you say sometimes just in your personal life, you've got to try and balance, this desire for hope with the realities of kind of your life and the realities of working. I think there was a quote that you've got to decouple your sense of worth and happiness from your long-term vision. Does it mean sometimes do you get too involved in all of this and in your research?
Yeah, you've clearly done your homework there. It's a long road. Yeah, it's a marathon of sprints. That's how I see it. I try to run at a clip of about 60 to 80% efficiency, and recognize that remind myself that the impact that I may have, I may not see it, and come to terms with that, and just be true to myself and do the thing that I think is the right thing to do, because that's what I'll be comfortable with.
Yeah, these are quite big themes, big ideas.
Yeah. And I got a sense of calling, if you will, when I went to the US, and I saw another thing I saw, to add to what I'd said earlier, was all the people who I worked with, like the professors who were in Rice University and MIT, they're really working on big problems. Like you have this podcast about global problems. Like they're really working on big problems. And in some cases I was like, wow, that's just too big. And then other cases I'm like, well, what else are we doing? If we can, then, should we? Possibly we should.
Well, I guess on that theme, plastic, and a lot of people are very concerned about plastic. And you see very emotive images of lots of plastic in the oceans, etc. But you mentioned in your introduction about specific focus on the reusing of plastic, but also a problem with black plastic as well. Do you want to expand on that and tell us what the issues are there?
Yeah, black plastic is when I had the idea of using plastic, I went into Andy Marin, and he said, use black plastic. That's a pain point. And he was right. Black plastic is a very interesting material, because it is itself a recycled plastic. Because black plastic is black because, like I said in the introduction, you mix plastics together, you get a weird kind of funky color, and it's not desirable. So you add a black dye or colorant to it, and then it doesn't matter anymore. It's just black. So black plastic is often already somewhat a mixed composite kind of recycled material. The challenge is that you can't recycle it later because it can't be seen by the detectors in the recycling systems. It's just a simple matter of that they just don't have machinery that can see it. And I thought, that's so bizarre, like that we've got this far and we can see black so well, but a machine can't see black at the speeds that these objects are flying through a recycling sorting system. And that's why black plastic is a problem. So black plastic gets collected, and because then black plastic is now usually already composed of a multitude of plastics, it is now a challenge to recycle, because when you try and melt it down, you got different plastics, they've got different melting points, so you're going to make it, it's going to be a glumpy goo. And so I thought, okay, this is an interesting pain point. But from a chemical perspective, when you really break it down, if you really want to get down to the nuts and bolts, it's carbon and hydrogen. And so thinking about it from that perspective is like, okay, how do I utilize that carbon and that hydrogen in the best possible way? What are the chemical mechanisms that we need to think about? What's the engineering principles that we need to apply? And it kind of just builds up from there.
This is going to sound like a dramatic change of tack here, but you are, I don't know, you tell me, a DJ, aren't you?
Mm-hmm.
Has that in any way influenced your work or what you do?
Yes, absolutely. I mean, yeah, definitely. How do I give a synopsis of how it's influenced my work or who I am?
Well, maybe first just tell us what sort of DJing you did and when.
Yeah, so way back in the day, I started out in my first official gigs were in the Ballybunion Atlantic Hotel in Ballybunion, County Kerry.
Is that where you're from?
No, it's not, but it's where I would travel to, and I stayed in the hotel, and I worked in the hotel and DJing, and I would DJ the Friday night. I helped with I wasn't I was the warm up DJ, and I would help the main DJ, and then the next year I went to Ibiza and I DJed down there, and I started off DJing CDs, which is what I was, compact discs, which is probably also something people might have to Google these days. And then I went back even further old school. Like next year, when the money that I raised from working that summer, collecting or sorting bottles and all the stuff you have to do with a bar and a hotel, I used to buy vinyl and records, and then I went to Ibiza and I got a gig there, and I worked the summer there, and then I chose to go back to school. And ever since then, I maintained DJing as my kind of one of my creative outlets. And I think it's very important to stay close to recognize. I'm very privileged to have had that opportunity and have that space. My parents would always say, "Turn it up." When I'd be playing the music, they'd be like, "Get those speakers out here." I had these big speakers. They were like half the size, the size of two children. And they were like, "Yeah, bring that outside to the living room and like turn that music up." So I'm very lucky to have that support. And DJing really, it taught me a lot of things. I think one of the things it taught me is about blending attitudes and moods and reading a room. And I think being a DJ, being a successful DJ or being a good DJ is a combination of two factors. One is reading the room and the other is blending the music, right? Which requires also oftentimes reading the room and picking the right tunes. And so in a classroom, I feel like I'm pretty intuitive about when's the right moment to maybe take a pause or ask a question, or I feel like there's a question coming. And I feel like that I became more attuned to that through the practice of DJing, of reading the room. And I think the aspect of DJing as well was, for an introvert like myself, is a perfect place to be at the center of the party without anybody needing to talk to me.
So standing in front of a big lecture theatre.
Yeah, basically. Yeah.
And is the blending of the tunes, is there an academic research parallel there as well? If you're bringing in lots of different ideas from different places.
Well, that's a very good very astute. I didn't think about it like that before, but yeah, actually, you could think about it like that. If I suppose if you're going to use that parallel, then it's like in DJing, the objective is to get everybody's hips moving, and then to keep that going, and to get that gyration going better and better and better, regardless of the song, regardless of the genre. Just keep that flow going. And I suppose with innovation and the science that I use to innovate it is kind of like that. It's like whatever it takes to get that process operating. If we have to learn a little bit of history, if we have to learn a little bit of engineering, if we have to do chemistry, if we have to go backwards and learn a little bit of physics, that's what we have to do. Because at the end of the day, what we have to do is solve a problem, not maintain and stick to a discipline.
I think good academics, like good politicians, often have hinterlands, wider ideas and interests that they can expand into. So that's particularly fascinating. I like that. Talking of politics, actually, I was going to ask about big picture stuff here for a minute and say, when it comes to your research, to what extent is politics and government involved? To what extent does perhaps a big decision made somewhere very far away impact the direction that your research might go in?
Massive impact. And I've really come to appreciate this, the effect of the impact and influence of policy and politics on science, thanks to my interactions with the Royal Society. I did a parliamentary pairing scheme. I went to Westminster. I was there for a week. Welsh Crucible, we went to the Shanad. But really seeing how a policy decision can be made and how or whether or not that gets enacted based on politics, and recognizing how different the two of them are, but also recognizing how it filters down in terms of regulations, laws, policies. And one key quote I remember, and I keep it with me, was from an event I was in at Cardiff, where there was an inventor there, and he gave his presentation, and he said he's been working on plastics recycling technology for 25 years. And it's only now that he's starting to be able to make headway, simply because the policies have changed. And I thought to myself, right, I need to learn more about this, because I don't want to be blindly, scientifically, naively working like an academic towards something, if really the bigger key factor is going to be policy.
The political will.
Yes, and the actual policies that are in place, and what the language of the policy, and how the policy is, whether it is enacted, is there any teeth behind it, who is going to do that? That comes down to politics. All the various dynamics. I realized I needed to learn more about the nuance of this, because I had, up until that time, been really just thinking about these very, very large problems from a scientific and technological perspective. And then that quote, to me, signified that I need to broaden my horizons again, to also take in the consequence of policy and politics.
This sounds like the kind of topic that requires a lot of collaboration with other people.
Absolutely.
So who do you work particularly closely with?
Well, on the point of collaboration, absolutely. You have to have conversations with as many people as possible. I in my class, EGSM 05, I teach this, that people should broaden their network and their horizons as much as possible. And in a course I took at MIT, or a class, this person said, stop worrying about your career, get on with it. His advice was, you should be networking to 3 people a day. And I also kind of had a similar reaction. Actually, I was more aghast. I was like, God, I'm going to burn out on my contact list without 2 weeks.
I was sniggering there, because I thought, gosh, that sounds like hard work.
Yeah. But if you think about it like work, it is. It depends on what way you think about work. But if you think about it as a job that you have to do, then maybe it is a little bit too much. But who do you have in your network? The people I have in my network, I love to hear about. The stuff that they're doing is phenomenal. It's fantastic. And if there's any way that I can help them, I love to be able to achieve that. And I try and keep up. I try as much as possible to keep up with 3 people a day. I'm not that good at it, but there is some fascinating work going on, and it's amazing how I read an article, I go, oh, that's very interesting, and just reach out to that person. And it's so few people would reach out to me based on the work that I do. But when they do, it's out of the blue, and I'm really thrilled to get it, and I respond in earnest. And I imagine the same for when I reach out to other people, and bit by bit, these people become a part of your network. So who are they? They're all the people generally I've either interacted with or be inspired by or had the guts to reach out to. A large variety of people from all sectors.
Other universities?
Yeah, I mean, there are university lecturers, professors, students who've moved to other universities that I've worked with. I mean, I'm still working with my colleagues back at MIT, still working with colleagues in Rice University. I just did a piece of work with someone in North Carolina. I had long conversations with colleagues in Cardiff, and thanks to the Welsh Crucible, I had lots of interactions with other universities in Wales. I'm going to have to go through a list and think about all the different universities, but many different universities. At sometimes at different moments, it's more intense interactions that I would have with them because we're looking at a grant and we're deciding, is this what we want to work on? How would we correlate our efforts together? And then there's other times where we just get swamped by what we have to do.
I know you said a moment ago that you might not even be around to see the final conclusions to all your hard work, but in the kind of medium term, I guess, or the medium to long term, if you could think of one really big, fantastic thing that came out of all of your work, realistically, what do you think it's going to be?
So I had this visualization exercise that I did thinking about my daughter when she's 12, 13, 14 years of age. And she's 2 now. And so she can speak a little bit, but she wouldn't quite understand this. But at that time, she does. And at that time, I talk to her, and I think to myself, and I say to her, she's asking me, you have this choice ahead of you, that you have this technology that could work on converting. It could make, even if it's only a drop in the ocean difference for plastics recycling, it could make a difference. And what do you do about it? And given the fact that, I mentioned that statistic that right now we're consuming one way or another approximately the size of a credit card of plastics a week. That saddens me, frightens me, and enrages me to think that that's what's happening to my daughter or anybody else's child or ourselves right now, that we've put ourselves in that position and this is the norm. If there's one thing that I would like to come out of it, is that when she's 10 or 12 or 13 or whenever this time is, sometime in the future, that quantity doesn't go up. And if anything, it doesn't go up, but hopefully it goes down and it goes to zero.
Now, there are going to be people listening to this who obviously are very interested in what you're saying, but they might be thinking, I want to study this or I want to work on this in the long run. What advice would you give those people?
Follow your heart. Be true to yourself. Think about problems. Look for problems and develop a fundamental basis, a skill set. Was it the judo master who practices one thing 1,000 times is more dangerous than the judo master who practices 1,000 things, or 1,000 different things. Get into the nitty gritty of something, and then learn how that thought process or learn how that skill set can be applied in different areas. My biggest advice at the same time is that's also a little bit airy-fairy, because you have to be practical, you have to be pragmatic. Like, some people love to do certain things, but at the end of the day, you got to put bread on the table. You got to think about this in the long game. You got to be patient and try not to get distracted. This day and age, distraction is something that I fight with on a regular basis myself, from daily distractions to weekly and monthly and seasonal distractions. If you find in yourself that you have a calling, or there's something that you just can't put down, an itch, yeah, scratch that itch, as they said in The Wire. Like, follow that passion and surround yourself with other people who will support you and believe in you, and find those people.
Well, I'm sure people listening to this won't have been distracted. It's been a fascinating conversation, Alvin. Thank you very much.
Oh, thank you.
If you want to find out more about Alvin's research, you can visit his personal website, www.alvinorbackwhite.com. That's all one word, the Alvin Orbaek White bit, and it's spelled ALVINORBAEKWHITE. To find out more about this podcast and Swansea University's research, visit swansea.ac.uk/research. That's all from us today. Thanks for listening, and thanks once again to my guest, Dr. Alvin Orbaek White. If you've enjoyed this episode, please follow us. I'm Sam Blaxland, and that was Exploring Global Problems from Swansea University.